Hello, guys. Happy Tuesday to you. We're almost at Thanksgiving. I can taste that turkey now. But in the meantime, let's make sure we finish this week strong. So on day 6, I gave you guys the practice multiple choice as homework. Thought we'd just look over that real quick. I'm not going to spend a lot of time on it here because you guys traditionally have been really good with proofs. But we see definition of midpoint, vertical angles, which leads us to know that we have a side, an angle, and a side, an angle, and a side of these triangles. So I'm pretty sure with a little side angle side, we can say that these two triangles are congruent. Now, as far as the next three, they're going to require, a couple of these are going to require you to give more than just one proof, but really, a lot of times it gives the game away a little bit here. So we're given this side's congruent to that side, this side's congruent to that side. We probably have an idea of how we're going to prove this thing. Looks like first we have to prove that ST equals TS. That means that this thing equals itself. Well, that's the good old reflexive property. And then from there, if it does equal itself, what postulate will prove these two triangles are congruent? Well, that's going to be some good old-fashioned side, side, side. Triple sides, like a snake. So we got reflexive, and there it is. Side, side, side. Okay, number 3. Ray A bisects DAB, and ray CA, this way, bisects DCB. So it cuts this angle into pieces. So we know we've got this and this that are congruent, and we know we've got this and this that are congruent. Okay? And so we're also told AC is, of course, going to equal itself, AC. We're also told DAC is going to be congruent to BAC. Interesting. Probably because we know these are bisected, so they're the same angle because it's been split in half. Same thing over here. DCA and BCA are the same. And of course, using the reflexive property, we know this equals itself. So then we say, how are we going to prove that this triangle is the same as this triangle? Well, it looks like we've got side, angle, side. See? Number 4. Looks like we're dealing with vertical angles, so we know angle is going to be involved here. We're told N and Q are the same. We're told NO and QO are the same. So along with that, we're also told that this angle and this angle are vertical. So how can we prove that these two triangles are congruent? What postulate lets us say that? Looks like angle, side, angle. Ooh, but then now we have to prove that another piece, MO, is going to be congruent to PO. So once we prove triangles are congruent, what lets us prove that their parts are congruent? Well, that's some good old CPCTC. Congruent parts of congruent triangles are congruent. So we got that one, guys. Let's see, is there one more? Oh, 2. Yeah, 2 more. Okay, sweet. We're knocking these out quick. So we've got angle 1 is the same as angle 2, and angle A is the same as angle E. We're also told that N is the midpoint of AE. So in other words, this piece and this piece are congruent because N is the halfway point. So then, if we're told N is the midpoint of AE, what lets us say AN and NE are congruent? Well, if it goes from words to math, we know that's a straight up definition of midpoint. Okay? So we know it's not going to be A, not going to be C, not going to be D. So immediately you kind of already know what it's going to be. But let's just double check here. So now we've got angle, side, angle. Angle, side, angle. Oh, so we can prove using some asa that these two triangles are congruent. And then, of course, how can we prove if these triangles are congruent? How can we prove that they're pieces? So BN and DN are going to be congruent. That's some good old CPCTC. And so finally, we ended on a short one. I know you guys will like that. AC is equal to BC. So this long leg is congruent to this long leg. And angle A and angle B are the same. Okay. Looks like we need to work with this angle then. And it's looking like we know this triangle right here and this triangle right here, they both share the same angle. Angle C is going to equal itself. This angle is going to be the same for this triangle as it is for this triangle. That's some good old reflexive property. And so let's see what we've got here. We've got angle, side, angle, angle, side, angle. Samasa. So that will be D. And there is your homework, guys. Now, on to day 7. So we're going to knock out this first page and wrap up this first video. And I should have the second video posted for you shortly after. But let's look at day 7 here, guys. And I'll be real with you. This is going to be a day where we finally bring in a little bit more math, a little bit more algebra. It's a little more algebra heavy. You're going to notice these last few days we really haven't done much math. It's been a lot of understanding concepts, being able to do proofs, things like that. Now, from algebra people, kind of like me, you may like today a lot. So we want to be able to solve problems with triangles that involve a midsegment. Now, when you hear that word midsegment, you probably think middle, and that's awesome. That's what I kind of want you to think of. It's kind of like middle. And what's it in the middle of? Well, let's take a look, guys. We just have two main things here, and just like always, what's one of them? A definition. And what's the other one? A theorem. Seems like we've been getting that set up a lot, which I like, because that means you guys get very digestible things here. And so let's see what the difference is. So the definition of a midsegment, it says that the midsegment of a triangle is a segment connecting the midpoints of two sides. Okay, so check it out over here. What would be our midsegment? It's a segment connecting the midpoints of two sides. Well, here's the midpoint of this side. Here's the midpoint of this side. Yep, and it's connecting it right there. And check it out. If BD is equal to DA, so this piece is equal to that piece, and BF is equal to FC, then DF is a midsegment. So there you go. Now, what do we do with that information? Well, here's where the theorem comes in. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel. So we see this is parallel to this. And here's the key. And it's half the length. So check it out. We know that, so two conclusions here. Parallel to the third side. So we know DF is parallel to AC. And we also know that DF, our midsegment, is going to be equal to, it's half the length of this full side. So 1/2 AC. So not only are they parallel, the midsegment is half the length of its parallel side. And so here's what I'm going to let you guys do. I'm going to let you guys try, let's test out your spatial recognition. Try and see if you can tell me which line segment is parallel to these three right here. Go ahead and give this your best shot, guys. Let's see how you guys did. So EF, going to be parallel to, looks like AB. AC, so this whole side is going to be parallel to this midsegment, DE. Those are connected. FD is going to be parallel to BC. So those are our three right there. If anybody's ever played Legend of Zelda, this reminds me of the Triforce from Legend of Zelda. It's kind of rad. I like it. A little old school. So here's kind of a little brain teaser for us. What happens now if we're dealing with this and we're told AB, this whole piece is 60. We're told DF, this smaller midsegment, is 40, and AC, this whole piece down here, is 100. Well, what then would DE, EF, and BC equal? So we've got DE, that is this piece right here. Well, it looks like it's parallel to this piece down here. So if this is 100, we know the midsegment's going to be half this length. So that would be 50. And I'm going to let you guys try EF and BC for me. Go ahead and give those your best shot. Let's see what you guys think. So if DF is 40, I look over here at BC and I say, okay, that's going to be twice as big. That's double whatever this is, so 80. And then EF is going to be half of AB. AB is 60. So EF is going to be half of that. It's going to be 30. Yeah. Now here's where we're going to get to throw it back a little bit. We're going to get to work with some old angle relationships here. Check it out. This is going to be back to like the chapter 2 days. A little bit of chapter 3. So we're told, here's our new triangle. We got UVW, and then we got UXY up here too. So we're told, hey, X is the midpoint of UV. That means this piece and this piece are the same. And Y is the midpoint of UW. So this piece and this piece are the same. So then, if UXY is 60, U to X to Y, if that's 60 degrees, find angle V. Find this angle right here. Now, wait a minute. Parallel line, transversal, hold up. Wait a minute. This angle and this angle, if this is inside these parallel lines and this is outside these parallel lines, what kind of angles would this angle and this angle be? Think back. Corresponding. These are corresponding angles. And so if that's 60 degrees, guess what? That's going to be 60 degrees too. Absolutely. Now check this out. What happens if we know this other angle? If UWV, so this angle is 35 degrees, okay? Find angle UYX. So find this angle right here. Additionally, find the measure of angle U, this top angle up here. Well, check it out. U to W to V, that's this angle. And isn't this angle and this angle the same situation as that and that? Yeah, these are corresponding too. So then UYX is also 35 degrees. And guys, if we know this angle and we know this angle, angle U is just going to be the third missing angle. So we say to find angle U, take 180 and subtract it by the sum of 60 plus 35. So we'll see what we end up getting here for angle U. We do that, 180 minus whatever 60 plus 35 is. Oh, looks like that gives us 85 for this angle up top. Now, what I'm going to let you guys do, I want to let you guys try number 3 and number 4 for me, and we'll double check these here in just a sec. You can pause the video. All right, so XY is 50. If we're trying to find VW, that's its parallel larger side. It's going to be twice as big as that mid segment. So that'll be 100 if that's 50. And then UY is this half. So if we want to find the whole piece, UW, that's just going to be double, since this is a half of the segment and this is half the segment, double it. Should be 84 for UW for the whole piece. All right, and then the last thing before we end video number 1, I really want to let you guys see what you can do with this one. So let's break it down real quick before I turn you loose. XY is a mid segment, so we know it cuts this in half. We know it also cuts this in half. cuts VUW. Now XY, we're told is 7, so we know the mid-segment length. We know UV, this whole piece, is going to be 10. And we know UW, this whole piece, is going to be 13. So what they want you to do, with the information you've been given, you're going to be able to find every single piece that is currently missing. They want you to find the perimeter of each triangle. So we're going to find the perimeter of XUY, and we're going to find the perimeter of the whole triangle, VUW. So let's see what you guys can do on these two. Give me your best shot. So we know half of 10 is going to be 5 and 5. Half of 13 is going to be 6.5 and 6.5. And if that's 7, that's going to be 14. So when we find the perimeter of the little triangle, we do 5 plus 6.5 plus 7, 18 and a half. And then to find the perimeter of the bigger triangle, 10 plus 13 plus 14. You notice something? This is 1/2 of this. That's kind of funny. That's half of this. So this triangle is literally almost half the size of the big triangle. So guys, we'll end it here. Part 2 coming shortly.